Okay, we'll start from here. Thank you. So welcome to webinar number 2 for Index Online. We will be doing this weekly as a tool to help people during these times right now. Obviously, a lot of people are stuck at home or perhaps underutilized in their work, not of any fault of their own. So we want to share our knowledge, and hopefully we can be of assistance to any corporation, company, or even individuals in the future. So today's lesson webinar is on about gas groups, specifically hydrogen. So to be or not to be, a play on words of Shakespeare, but can 2B plus H2 equipment be used in a 2C hazardous area classification? Now, this is not straightforward, so this is the reason for this presentation. There is confusion within the industry, uncertainty, and we hope to address that. So this is an example. If you look at where it says Zone 2 apparatus group under the legend, it indicates this area is a 2C gas group. 2C can mean hydrogen or acetylene. Now, immediately looking at this enclosure, there's certain things about it that would indicate to me that that piece of equipment is not rated 2C. Now, if I were to ask you a question, pull. Let's quickly ask everybody a question. This is a multiple choice question. Can you please give your input onto which gas groups you believe include hydrogen? Which gas groups of the following include hydrogen? So multiple choice, you're able to give multiple answers. Mm-hmm. Is that correct? One second, people. Okay. Can everybody see the screen correctly? Okay, so of people's answers, the correct answer is 2C, 2B plus H2, and B. That refers to North American. Next. Let me turn off my camera. I think you guys will be able to see much better. Apologies, I believe this is supposed to be another screen. 1 second. Okay, so when we go into further detail and look at this device, things that we notice are these right here, the hinges, would indicate this is not a 2C piece of equipment. When it comes to 2C piece of equipment, we're talking about very tight tolerances that do not allow for the use of hinges. Hinges do not allow you to use a 2C equipment. I cannot see anything. 1 second. 1 second, everybody. Apologies. Now is okay? Okay, I think our poll is now closed. Okay. Still with the questionnaire. Okay, let me close it. Can you see the screen now? Okay, apologies. Still getting up to speed. Okay, so when we look at this piece of equipment, we see hinges on it. With a 2C piece of equipment, the hinges shall not be there. The tolerances when it comes to using a hinged door, you cannot guarantee the same gap on the side where the hinges are to the side that the hinges are not. Now, when we look at this piece of equipment, the area is 2C, but the equipment was selected as 2B+H². Yes. Is this a better view? This better view for you guys? We'll have to go with it. We'll have to go with it. Sorry about the presentator view, guys. It's not going with how we want. Okay, so this installation, they chose a 2B+H². Now there's issues with that where this will cause confusion between engineers and inspectors. Inspectors will perhaps say that this is not rated for a 2C area because during their training, they may not have been told about 2BH2 being acceptable in a 2C area if the 2C area is only for hydrogen. So one solution that some companies go with is where in the legend or in the notes, they mention 2C, but bracket 2B+H². I do not agree with this. This will also cause confusion. Why? Well, if that area is only assessed for hydrogen, why would it be 2C? What about acetylene? Can acetylene be present? We don't know. It could be, you would have to look within the datasheet for the sources of release. So this can cause confusion. Here's the point that I was mentioning for 2C gas groups. For EXD with flange type, there's restrictions on it. They're only permitted with a very tight gap tolerance of 0.04 millimeters, 0.04 millimeters. That is why you will not have a hinged type flange EXD 2C. It's too tight of a tolerance to guarantee with a hinge. We're talking very finite measurements. So, personal competency for the technician and engineer. Have they been trained in the use or the creation of a hack? Most of the time, no. From own experience with certain competency programs, whether EEHA or other ones around the world, many technicians and engineers are not aware of how the hazardous area classification is determined. There's environmental conditions, release data, calculations of release, ventilation characteristics, the evaluation of the effect of the ventilation, effects of a release, determination of minimum requirements for applicable equipment. Also, dispersion patterns. How will that gas turn into a liquid and disperse up or down? Are they aware of the importance of the note sections and reference drawings? So if we look here, there's a lot of reference documentation. Now, how many times does the inspector get that documentation? Slim? Rarely? None? As to who can do a hazardous area classification drawing, that will be determined by the responsible person of the company. So if it's an EPC, the construction company, during the feed stage, they would have the responsible engineer. We'll go into that further details of which engineers are required, because one engineer is certainly not sufficient. As for which training shall apply, that depends on the end user or the EPC's responsible person. There are certain ones such as IECEx COPC, Unit 2 for classification and Unit 9 for design. Engineers that have that would probably have a higher level of competency or proven levels of competency. Now, for the sources of release, which shall indicate the flammable substances, where can you find that? Usually you would find it in the reference drawings under the notes or legend, and then you'd be looking for something here that indicates the different types of hazardous substances, whether hydrogen would be listed there or not, or acetylene would identify if that 2C area is only hydrogen or hydrogen and acetylene. These questions that I've been answering, by the way, have been coming from students. Okay, why the confusion? Let's go back in history. Classes and divisions method, the North American way, which has been used around the world, even in Saudi Arabia and other locations, has hydrogen as a group B gas. So its distinct characteristics differ from group A acetylene. This started in 1920s and 1931s for division and then classes. So acetylene is just group A. It's clearly identified under API 500 North American way. Group A, acetylene, done. Group B, that's when it starts talking about the maximum experimental safe gap and the minimum ignition current ratio. So there's big differences, meaning acetylene is very dangerous and hard to comply with, while hydrogen is less so. So what happened in IEC? Well, in the zones method under IEC or NEC 505, it's confusing because you only have had 2C, 2B, or 2A. So under 2C, we had acetylene and hydrogen. So as we see, that causes confusion in the industry. We'll go into details of why it's a problem. But under NEC 505, they list 2B+H² as only an equipment gas group option. So under NEC history, they brought zones into effect in 1996. Apologies. Now, under IECEN 60079, 2B+H² is also an equipment group option. Now, The importance is the plus symbol is used to indicate the particular gas that the equipment is certified for use in a hazardous area where that gas or vapor may be present. So if there is only hydrogen and not acetylene present in that area, that indicates that you only need to test to 2B, do inspections to 2B, and the equipment for H2, 2B H2 means it can go into an area that is defined as 2C hydrogen only or 2B+H² hazardous area. Now, based off the last slide, we'll put out this poll. What are the advantages of the class and division system? Now, there's multiple answers to this. What is the advantages of the class and division system for identifying hydrogen? %10 voted. %30%. We'll wait till we get up to about the 70% range, and then I'll close the poll. %55%, 60%. Give me another 10 seconds. %70% and closed. Okay. So 32% said there is none. The IEC method is simpler. I would tend to have a different opinion than that. We'll explain in a second. 14% that it is understood by all. I don't think that's the case. People that have not worked with North American standards or 500 or 505, they perhaps may not know this. The 75% of people said that the individualized gas groups is simpler and cheaper for manufacturers, for installers, for designers, for maintainers, because there's less confusion. A is only acetylene, done. B is hydrogen and others. So that separation makes it easier for people to understand. Now, where I say sequential order, in training programs that we have put on under different schemes, IECEx, Competency, others, there is confusion in the industry in many countries when it comes to gas groups and temperature classes, because T1 is the hottest, the most dangerous piece of equipment and most strict restriction for an area that there is. So you would figure 1 would go with A, 2, B. So when you think of a gas group 2A, that's actually an area that has a gas group that is not the most dangerous. But in the North American way, A is acetylene. It is the most dangerous. So by it being backwards from each other in the IEC between T ratings, temperature classes, and gas groups, that does cause confusion. But that is open to interpretation. So please don't take it as a absolute truth. Next slide. So 60079-10.1, classifications taking into account. Ignition characteristics of gas or vapor is based on ignition energy and ignition temperature. This recent revision from 2015 has removed the words gas groups and temperature classes because there was confusion, thoughts that 2B plus H2 was not a gas group for an area. But that is changing. This is indication of that. The consideration is the ignition energy and ignition temperature, which you would find in the sources of release data sheet in the notes. Should be, not all engineers put it there, should be, which you reference when you're referencing your hazardous area classification. Now, further clarification of hydrogen. Well, in the latest standard, it says hydrogen is commonly found in mixtures of flammable gases such as refinery process streams. So, hydrogen is commonly found. The hydrogen economy is taking off. Vehicles, ships being powered by hydrogen. Acetylene is nowhere near as common within our industries, LNG, oil and gas. Acetylene, I know of for welding, but other processes, it's rarely ever found. So EXD products that are only tested to 2B plus H2, the testing and certification of this equipment is much simpler. Next slide. Oh, also under 6079-1 for EXD, double marking can be applied for a specific gas. So 2B plus H2, if the enclosure has been submitted only for the test of the specific gas, but also to the necessary of the lower group. So there's no need to test to 2C, specifically hydrogen, acetylene. Next slide. This is an interesting case that is coming up more and more. Australia, Canada, US, Norway, it's really taking off. So we have fuel stations, triple use stations, where we have petrol or propane, hydrogen refueling, and electric vehicles. Is this safe? I would err on the side of caution and say that this is perhaps not safe, because our ignition sources, the electrical vehicles and charging stations, are quite interesting. Then for the fuel, well, we have hydrogen, petrol, propane. So we have a lot of fuel, we have a lot of potential ignition sources. There's certainly a lot of oxygen around. And hydrogen, even static electricity to the minute detail, will cause ignition of hydrogen. There's many static electricity considerations with hydrogen to multiple times the amount compared to petrol. So I find it quite interesting if a non-hydrogen car were to pull up next to the hydrogen station. Does it have the adequate protections? Now, how was this facility classified and designed, and which equipment was selected? From my understanding, the regulations are not in place for these type of installations, nowhere near to the level of LNG, oil and gas, offshore, onshore plants. Why? Because there haven't been as many explosions of these fueling stations or of purely hydrogen refineries and fueling stations. They exist. I will send you links in our follow-up email to show you explosions of hydrogen fuel stations. Now, if this was defined a 2C area with 2C equipment, the manufacturer is looking at an expensive and difficult to build item restricted to less than 5 liters. If it's a flat 0.5 liters for a EXD type, flange type enclosure. For the installers, once again, it's more expensive. 2C equipment costs a lot more. You have to be a lot more careful. There's a lot more difficult tolerances. Now, the end user, obviously, it's expensive. If there's no acetylene here, why are we using 2C equipment? Confusion for engineers and technicians when 2B+H² equipment has been used. We experience this on nearly every project we run across. Some of you may absolutely know the answer to this already, but is everybody aware of this? Certainly not. It's a continuous source of discussion. Now, if this was a 2B area, would this be fit for purpose? No, and 2B equipment would not be fit for this installation. Now, if it was a 2C area with specific mention of 2B+H², would it be acceptable? Yes, but there is confusion. There will always be confusion when you are identifying two different gas groups, two different options. If there's no acetylene, why mention 2C? Okay, what is the ideal solution? Well, 6079-10.1, once again, here down in the information, many end users and EPCs are now integrating where that the gas group should be considered 2C or 2B+H². If you have no acetylene, there's your answer, the most ideal answer. It removes the confusion for the hazardous area classification, for design and selection, for inspection. Your technicians will no longer be confused. It's a 2B+H² area, and they either have 2B+H² equipment or 2C. 2C even better. Manufacturers, the reduced costs are the big one. They can have bigger enclosures. It's easier to manufacture. Testing and certification is much easier. When you test to acetylene, there is, during the explosion-proof testing, flame-proof testing, acetylene, when it is ignited, lets off a lot of carbon. It lets off a lot of carbon, which embeds itself into a flame path, and then there's a whole other load of issues. Now, the EPC and the end user. And remember, the end user accepts all the costs of the manufacturing, certification, design, and what the EPC does for them. And they also accept all responsibility. So for them, they have reduced costs, more equipment and manufacturer selection options. They don't have to be held to only one model or one manufacturer of enclosures. Once again, less confusion. So during the complete life cycle of their facility, could be 20 years, 30, 40, some with 50 years. So as people roll through the plant, you will not always have employees for the entire life cycle of your plant. So you can reduce the confusion, reduce money, reduce time, increase quality. Less confusion, always a good thing. Now we're going to open up another poll for you guys. What is the most ideal? So which would be the best solution to classify an area that has hydrogen and ethylene? Classification of the area, not of the equipment. 33% voted, so let's get that up to 70%. Now, when talking about confusion, money saved, please think of that, what we just talked about. What is the most ideal? If acetylene is not used in the process, and there's a low chance that it will ever be retrofitted and include acetylene, what would be the most ideal? 74, we'll give it another 10 seconds. Okay, so some people listed 2B. That's not the solution that you would look for. H2 is always going to be a 2C gas or 2B plus H2. So the answer of 2A plus H2, we have 6% for those two answers. So those are not the solution you would want to look for. 34% said 2C, while 53% said 2B plus H2. I understand the contentiousness of this, but if you are working just in engineering or working in just as an inspector, perhaps you would not have the feedback from others in other departments. So, do you speak to the manufacturer? Do you speak to the testing and certification body? Do you speak to hazardous area classification engineers? Do you speak to the designers and procurement people? Do you speak to the responsible person for the inspection and maintenance for the complete life cycle? Some of us have that experience crossing silos. It is a contentious issue all the time. So why 2B plus H2 over 2C? If acetylene has not been identified in the hazardous area classification, it's not needed as 2C. You have the cheaper, simpler, more efficient option. The commercial approach is most ideal for everybody, from the manufacturer to the hazardous area classification engineer, to the designer, to procurement, to maintenance and inspections of the complete life cycle of the facility. 2B plus H2 identified on the hazardous area classification drawing, and that type of equipment is most ideal. Yes, you can identify it as 2C, but at the very beginning, we showed you an example that was in Europe, and I have many other examples that would show that this happens continuously, wasted time, money, and talking about the issue endlessly. So at the end, you guys will be able to ask detailed questions, okay? So, classification solutions made easy. We now have an online hazardous area classification tool. What it allows us to do, which we've attached a document for you guys to download. You should be able to see it under handouts. Under handouts, we give our website and give you an example of what documents are required for hazardous area classification. So while you may not use the services, it is a source of information to understand what documentation you require, or that the hazardous area classification engineer required in the past to come up with his classification. So, another poll question. Why is it crucial for the classification engineering team to include process, mechanical, electrical instrumentation and control, and safety engineers? This is a multiple choice question. Multiple choice. There is no wrong answers, but there definitely is one that is not the correct answer. Well, all the other ones, perhaps consider. 55%. Wait till we get up to 70, and then we'll close the poll again. Give another 10 seconds. There we go. Good participation on this one. 81%. I'm going to close at 5, 4, 3, 2, 1. Okay, 83% voted. Very good on that one. Thank you. It isn't the safety. The safety engineer specialist is the responsible one. I would not myself ever choose that option. Safety. What is their competencies in hazardous areas, in electrical, in process, in chemicals? I would not, sorry. 3% on that one. Now, 29% for 2C for hydrogen 2 gas only. I wish that percentage would be higher as we went over this presentation. The amount of time wasted talking if a 2B+H² equipment is okay in a 2C area is certainly, yeah, wasted time and money. 46% for the 2C plus 2B, or 2C bracket 2B+H² causing confusion. I agree with that. Definitely will cause confusion. 83% said all considerations must be accounted for. That I would expect to be a little bit higher. I'd expect 100% to give that answer, but still really good. Dispersions of a release is often overlooked. Correct. Some liquids or gases that are released change state. A gas can become a liquid can become a gas. Its dispersion patterns need to be known to accurately classify the hazardous area. It can be dangerous if the correct equipment is not selected by the hazardous area classification being insufficient. Okay, we'll hide that. So back to our slide. We have this online tool. We're giving awareness to you guys, a bit of free awareness to go over all the topics we've gone over, give you an identification of the different standards that may apply all around the world. Within Australia, they apply AS/NZS 6079-10, but also on plants, they also do apply API RP 505 classifications. But each end user has their own input. Local regulations also apply. So it is case-by-case basis. So we want to thank you for your time. I see that it's gone about 40 minutes. So right now we'll open up to any questions. If anybody would like to have any questions for the next 10 minutes, we are open and available. So please indicate in the chat if you have any questions. 1 second. Questions. Okay. Now we have one question. What is the cost difference to accredit 2C equipment versus 2B+H²? That percentage can be variable. It can be anywhere from 10% difference to hundreds of percent. It really depends on the piece of equipment. But the testing time and price is definitely less, and it is very good for control panels. Control panels, like you saw with that big door, that swinging door with hinges, control panels is definitely the one where 2B+H² is much more ideal than 2C, identifying it as just 2C without acetylene or fully 2C with acetylene. What about gas detectors? How can they affect the hazardous area classification? Gas detectors can be used as a mitigation technique. It's a safety device to be able to shut down a process. Let's say we are talking about a battery room. Batteries under charging or under hard use produce hydrogen. If they were to get up to a 1% lower explosive limit, it can be built into the logic to shut down the charging of the batteries and to increase in ventilation. So they could define the battery room as a zone 2 negligible amount. So equipment would not have to be zone 2, or it could be classified as non-hazardous. That is an option, but it requires a lot more programming, logic, correct equipment with SIL, safety integrity ratings. Since 2C enclosures might be size big and heavy, how can we use hinges for covers? Well, you can't for these absolutely big enclosures, because the acetylene with flange type can only be up to 0.5 liters big. So that's as big as it can go. So if you're talking a big enclosure, all you can do is 2B+H², or if you have a thread, there are some analyzers that instead of having flange type, they have threaded type. So a threaded cover, and then it is rated for 2C. But if you want a big open door for easy accessibility, it can't be done for anything that's bigger than 0.5 liters, which is quite small. Sorry about people not being able to see the answers to any of the poll questions. We will share those with you. Also, we should say that for the gas detectors, it is not a standalone solution. I think, as I said, there are other considerations that have to be included. Shutdown of non-EX equipment, ventilation has to be guaranteed. Anything that is on UPS shall have to be EX because the power would still be on. There are shutdown and alarm features that must happen. So it is quite a lot to it. So when we talk about anything on UPS, you're talking about the battery transfer switch, you're talking about the phones, you're talking about the fire and gas devices, any of the SIS devices would probably also stay online, also the ventilation fan. But EXE is always a 2C gas group. Primarily what we are talking about right now is EXD equipment. The very first type of EX protection technique to existed was EXD, explosion proof. How does it have any difference, for example, for EXE for 2C and 2B+H²? I think we answered that. EXE is always 2C. Do you have a table which shows in which plants there is acetylene? We could find that and perhaps show an example, but acetylene in a process is, there's a few instances, but it's not as prevalent, nowhere near as prevalent. Can they make a non-classified zone 1 or 2? Okay, so I think what he's asking about is, can you make a zoned area a non-hazardous area? Yes, that is the point of a pressurized enclosure, or a ventilated, or a pressurized or ventilated building, such as a turbine enclosure, let's say GE, Baker Hughes. A lot of times they will say internally that it is not a zone 2 because they have it built in with ventilation and purging, but also have the shutdown logic and gas detectors and all these different safety systems controlling it, where if there was a gas release, there is immediate shutdown. So they do a risk assessment to ensure that nothing possible could happen. Now, next question is, one of the next topic could be selecting cable glands for direct or indirect entries into EXD. Cables, how they're gas tight, transmission along them. Okay, I think that's a response to, after the presentation, you will receive questions on what your thoughts are on this presentation and also on potential next topics for next week. So please share that information there. Just looking to see if there's any more questions. 9:48, 9:49. Does anybody have any more questions or any comments? Examples of the plants that would have acetylene, we would be looking at labs, chemical facilities, pharmaceutical. The pharmaceutical one is one that I have less experience with, but we as a company, we're a workforce of 45 people, a lot of engineers that do hazardous area classifications as part of HACS Online. And we can show examples of these, but in oil and gas, LNG, it's less so. Somebody's asking, what about olefin plants? I am not sure what an olefin is, what type of process that is. So I will look that up and respond to everybody in an email, hopefully, in our follow-up email, hopefully at the end of today. Somebody is asking me about questions as to the spread of locations of the attendees. Yeah, there are people from, I see, Italy, Tunisia, Australia, UK, Hungary, South Korea, Malaysia, Brazil, America, Canada. So it's looking really good. Thank you. Thank you, gentlemen from Australia. Myself, Michael Merrington, and ARPAT appreciate your good word. Another question for the EXD2C enclosure. At what condition does there need to be a barrier gland? That one's a contentious issue. 3 meters of cable or less? Or is the cable circular, compact? Will water, is it non-hygroscopic? Will it not absorb liquids up the cable? Is it a good quality cable? That's a question for another presentation. Glanding and cables is for a complete other one. Next webinar, maybe the next webinar or the one after that. We at Linde, a chemical facility, I believe, have acetylene manufacturing and filling facilities. So I'm guessing they fill acetylene bottles perhaps for the welding industry. That would be a very important plant where 2C full stop all the time. Is EXD 2C equipment with hinge door acceptable in a zone 2? I don't think you're going to be able to find that 2C hinge door equipment unless it's only for hydrogen. So you need to take into account all the things that we've discussed and then apply that knowledge. If you need any more assistance, please feel free to contact us. Okay. I want to thank everybody for your time. I think that's all the questions. And yep, so we got up to about 42 attendees, so thank you very much. And please be in touch. We're always here to assist any potential opportunities for training, for area classification, and such. Thank you very much. Have a good day.